In 1751, William Hogarth etched Gin Lane, a portrait of despair. Among its horrors, a mother pouring liquor into a baby. Remarkably, science only began to recognize alcohol's effects on the fetus a few years ago.
Fetal alcohol syndrome was discovered by a resident in our department of pediatrics in 1970. Christy Ueland was doing a study of infants who were small for gestational age, infants who were born on term but were little. And among those children, she found a few children who looked alike, who were very small, who were all retarded, and whose mothers all had a history of heavy alcohol use.
Although the report met with skepticism, others confirmed that alcohol affected both body and brain. But what of the effect on the emerging mind? In Gothenburg, Sweden, Marita Aronson studied babies with fetal alcohol syndrome. She found that alcohol could cause damage in very subtle ways.
Many of these children have problems. They have hyperactivity, they have impulsiveness, they have temper tantrums, they have short memory span, they have perceptual disorders.
These shapes were copied by two children the same age, one normal, one with fetal alcohol syndrome. And here, a child with the syndrome who tried to draw a human figure simply couldn't stop drawing noses and eyes, a sign of damage to the frontal lobe of the brain. The behavioral effects of alcohol range from the most subtle to the most severe. But what does it actually do to the brain? In the 1970s, Sterling Claren came up on a clue.
At that time, we had the opportunity to study the first autopsied case of an infant with fetal alcohol syndrome. And we were able to get the first real visual and graphic evidence of how devastating this condition could be to the human brain. This is a picture of that first brain compared to a normal human infant brain. The first thing that's obvious is that the brain is very small. But there's more wrong with this brain than that. You can see that the gyri, which are the normal brain squiggles, are really rather flat and thick. This is a cross-section of a normal infant brain. These are the size of the ventricles, the holes in the center of the brain. And you can see how thick the white matter is and how the gyri kind of form convolutions around the brain. This is the exact same section of that brain of a child with fetal alcohol syndrome. You don't have to be a neuropathologist to see that every single part of that brain is malformed. The holes in the center are way too big because there's so little white matter to fill them in. The brain density is really reduced, and that normal convolutional pattern of the brain has been lost. We get a clue to understanding how this kind of a malformation could come about by looking at the tissue microscopically. This is a section of the cortex of the cerebrum. The normal surface of this brain is in fact here. And then there's the stuff that's covering the brain that looks like it's in fact erupting through the cortex. This is in fact a malformation. It's a hodgepodge of all the different cell lines, all the different brain elements that go into creating the brain. It's as if the cells of the brain, when they were migrating to their final homes, didn't know when to stop and continued right on through and erupted onto the surface through little bridges like these and just came up onto the surface and became scrambled. These kinds of heterotopias or cell groups that are in the wrong places are typical of fetal alcohol syndrome and would suggest that alcohol dramatically interferes with cell migrations early in brain development.